Okay, YouTube, in this last video on solving radical equations, the interesting thing is that we're solving no equations whatsoever, but we're solving radical inequalities. But I will say this, to solve a radical inequality is pretty much the same process that you're going to see with solving a radical equation. So let's go ahead and consider what I have here, which is 3 times the square root of x minus 4 is less than or equal to 8 and not equal to 8. So we would say that dealing with something like this, if we're really going to treat this like we would an equation, then the idea would be we're going to isolate the radical, and then what we'll do is we'll exponentiate both sides to get that to go away. So with what we have here, which is less than or equal to 8, let's go ahead and start by isolating the radical. We're going to add 4 to both sides. So we get 3 root x is less than or equal to 12, and then we're going to divide both sides by a 3. Now, because we didn't divide by a negative, this sign right here is going to stay the same. It only switches if you divide by a negative or a positive, both sides of an inequality. So this equals 4. So to finish this off, what we're going to do is we're going to go ahead and we're going to exponentiate both sides now. We get the square root of x squared as x less than or equal to the square root of 4 squared is 16. So one would think that all of the numbers less than or equal to 16 would work here. And actually, we could just pick one out. I suppose if I picked 9, you put a 9 up here, we would get 3 times the square root of 9. 3 times the square root of 9 minus 4 is less than or equal to 8. Let's see if this does actually work. We get 3 times 3 less than 4 is less than or equal to 8. I suppose we get 9 minus 4 less than or equal to 8. I'm already thinking what it equals. 5 is less than or equal to 8, which is true. So that works. And 9 is less than or equal to 16. So by the same right, would negative 1 work? And I suppose if I show you this here, we get 3 times the square root of negative 1 minus 4 less than or equal to 8. Is this also true? Suppose I would argue that it is not. And the reason why is, of course, because we have an imaginary value here. So one thing that I'm going to mention in this video is this. We're going to write solutions up here. Solutions. I'm going to write that our solutions are all numbers less than or equal to 16, as I found over here. So don't think that you're going to be really confused. But one thing I do want to mention here is this. What is inside the radicand has to be non-negative. And what we mean by non-negative is that it has to be greater than 0. It can be 0. So what we're going to do is this. When you're solving polynomial inequalities, we're going to find the domain of the function. And in order to do this, we're going to set the radicand greater than 0 if an even indexed root. I'm going to leave this little note up here. And by even index root, I guess I mean like a square root or a fourth root or anything where you couldn't have, say, a negative in here in the first place. So what I'm going to do is I'm going to grab this x right here, this expression in the radicand. I'm going to say, okay, well, domain. Let's find the domain. What I would have to do is say that this thing right here has to be greater than 0 and then get x by itself. Yeah, I paused for a second because I wanted you to think about that because x is by itself. So what this means is this, essentially. Our solutions, greater than or equal to 0, sorry, it can't be negative, it can be greater than or equal to 0. Our solutions are all numbers that are between 0 and 16, including 0 and 16, okay? So if you wanted to write your solutions as x is less than or equal to 16 and x is greater than or equal to 0, that would be the same thing as what you've got written right here, okay? So what we're going to find for the solutions to a radical inequality are all of those that we find algebraically. That would be these ones right here, plus excluding, I guess we'll say, excluding all of those that don't fit in the domain. So let's look at a couple of other examples here. We'll look at a square root example inequality and a cube root inequality. So let's go and take a look at A. We've got 2 times the square root of x minus 3 is greater than or equal to 3. Because I'll treat this just like an equation, I'll go ahead and add 3 to both sides. We've got to get this radical by itself. We've got greater than or equal to 6. We'll go ahead and divide by a positive 2. So we get the square root of x is greater than or equal to 3. And then we'll go ahead and exponentiate both sides here. It looks like we're going to need a 2. So we get x is greater than or equal to 9. Now, I want to point this out here. If we were to take what's in here, we say domain. Let's go find the domain. Domain. We're going to say x has to be greater than or equal to 0. Whatever's in here has to be greater than or equal to 0. So your answers have to be greater than or equal to 0 and greater than or equal to 9. I would say only greater than or equal to 9 because it would have to be where these two have answers in common, where your domain overlaps with your solution interval. So we say the solutions are all numbers greater than or equal to 9. And at the same time, of course, they couldn't be negative. So now looking at letter B, my favorite part about letter B is that it is a cube root. It's an odd index. So what this means is our domain is not going to be restricted to being only non-negative, okay? So we would say that looking at this here, I'll go ahead and rewrite it. We have 4 times the cube root of x plus 1 is only less than and an 8. So we'll go ahead and divide both sides of this by 4. So we would get the cube root of x plus 1 is less than 2, and then we'll exponentiate both sides here to the power of 3. So we would get just x plus 1 on the left is less than 8, and then subtracting 1 from both sides of this, we end up with x is less than 7. So now here's my favorite part about this. The solutions are all numbers only less than 7. So now, why don't I have to set what's in here greater than or equal to 0? Why don't I have to do this? Well, the reason why we don't have to do this on this one is because you can take the cube root of a negative. It doesn't have to be only non-negative things in here. So our solutions are just x is less than 7. Cheers.